Okay, now we begin our study of complex numbers in polar form. So we're going to develop the numerical values for that. And so what I'd like to take you to is, I don't have my book open at the moment. It refers to a right triangle. So here we go. A right triangle, and let's talk about one in the rectangular coordinate system in the first quadrant to be specific. So let's talk about a vector, maybe that looks like this and has an arrowhead on it, and then I'm going to drop a perpendicular to the x-axis, and I'm going to call in this right triangle this side x, this side y, and this side r, and this is theta that we're speaking about. So remember that the cosine of theta is equal to x over r, or the cosine of theta is the side adjacent over the hypotenuse. But when we take this statement and multiply both sides by r, we have the r's cancel out, and we have x equals r times the cosine of theta. So to find the length of this line, we take the magnitude of the hypotenuse times the cosine of the angle to give us the length of the line. Likewise, if I wanted to find the side called y, the sine of the angle is called the side opposite over the hypotenuse, or y over r. And when I multiply both sides of this equation by r, the r's cancel out, and I have y equals r times the sine of theta. So this value right here could be found by taking r times the sine of theta. As well, please remember that the Pythagorean theorem applies here, and I know we know it as a squared plus b squared equals c squared, but also note here it could be x squared plus y squared equals r squared right here. And then finally, this angle theta can be defined if we're working in terms of the real and the imaginary piece of a complex number that ends at this point. Tangent of theta might be what we would use here to find the size of the angle, which is defined by y over x. So if a complex number in rectangular form is a plus b times j, or x plus y times j, then x up above there just a minute ago we said was r times the cosine of theta, and y was r times the sine of theta. There was a j here, don't forget. So what we have then is r cosine theta plus, and I'm going to put the j in front, I'll tell you why in a minute, j times r times the sine of theta. Actually, and I'll put the j in front here now, truly, in a minute. I'll put it right there. This j times r times sine theta. And then see how both of these have an r in them? I'm going to factor that r out. And then I can write this as r times the cosine of theta plus j times the sine of theta. We always put the j in front to not get it mixed up with the symbol theta, because sine theta is one factor, if you will. It's j times the sine of some angle. All right, that was a little bit possibly confusing. Let's go here and see where I was going with this. So if I want to convert this complex number from rectangular form to polar form being this r times the cosine of theta plus j times the sine of theta, and here's x and y, I'm going to go ahead and graph this thing, and I'm going to go to the right 6, 4, 5, 6, and go up 8, 5, 6, 7, 8, and I'm going to draw a vector quantity to that spot. I'm going to complete this out by drawing a straight line down here. I wish that hadn't jumped, so I'm going to see if I can do that again. Oh well, I'm going to leave it. And for this right triangle, where this real part is 6 and the imaginary part is 8, and I have and can find this angle theta, what I want to do is I want to change this into r times the cosine of theta plus j times the sine of theta. And to do that, to find r, I'm going to use the Pythagorean theorem. So I'm going to take 6 squared plus 8 squared and take the square root, and you're going to find that that's equal to 10. And then to find theta, I'm going to remember that if I took the inverse tangent of the side opposite over the side adjacent from this angle, or the y value divided by the x value, I would get, pretty sure that's a 53.1 degree angle. And I could now write, and I'm just going to draw over this red line right here. I could write that as r, which is 10, times the cosine of 53.1 degrees plus j times the sine of 53.1 degrees. And I just want you to know that this in red is the same thing as the 6 plus 8j in black. This is called rectangular form. This is called polar form. Pretty easy to do because it's stuff we've done a lot with vectors. So this one, I would go to the left 6 and then up 8 right here. So I'd be speaking about this vector right here, but by the reference triangle right here, this being the -6, this being a +8, my r value is still going to be 10 because I'm going to take 6 squared plus 8 squared. I don't bother with the negative sign to get 10. And this reference angle is still going to be 53.1 degrees, but now because I've gone to the left in the x direction and up in the y direction, I know that theta in the second quadrant is 180 degrees minus that reference angle of 53.1 degrees. And so that's equal to 126.9 degrees. So I would write this -6 plus 8j in polar form by stating its r value times the cosine of its angle plus j times the sine of its angle. And I want to now introduce the shorthand form for this. Sometimes we'll write it as 10 at an angle of 126.9 degrees. That's how we represent a vector sometimes. That's the magnitude, that's its angle. But please, you have to understand that if I was to distribute this 10 times the cosine of the 126.9, I'd get a -6. And 10 times the sine of the 126.9, I'd get a +8. So this does mean this. This is just shorthand for that. Let's turn the page and do a few more. So I'm sticking with the 6s and 8s on purpose. So here I go to the right 6 and down 8. So I believe that's right about there. And so that vector is way down here. Its magnitude is still, with this being a +6 and this being right here being 6 and this being 8 units long, this is still 10, but the -8 causes this to be a -53 degrees, or let's take 360 and subtract the 53 degrees. So my r value is still 10, my reference angle is still that 53.1, but because I'm in the fourth quadrant, theta in the fourth is always 360 minus that reference angle, which would be 306.9 degrees, I believe. And so finally, we would write this 6 minus 8j in its polar form as 10 times the cosine of 306.9 degrees plus j times the sine of 306.9 degrees. I'm going to try to squeeze a couple more in here, and these now are no longer just sweet values such as 6 and 8. So let's draw the rectangular coordinate system, and let's just estimate. This one is I'm going to go to the left 43 units and down more, so down 56 units. So I'm going to draw it like that is what I'm going to do. And then I'm going to drop a perpendicular to the x-axis so I can see my right triangle that has a leg of 43, a leg of 56, and now I have to find my r value. So my r value is the square root of 43 squared plus 56 squared, and I'm not going to worry about reducing this or what that turns out to be. I'm just going to take the square root of that and get 70.6. My reference angle is right here, and that reference angle is found by taking the inverse tangent of my y value of 56 divided by my x value of 43. Don't use these signs. I just want an acute. I want an angle between 0 and 90 degrees. This should turn out to be 52.5 degrees. Finally, because I'm in the third quadrant, I'm going to take 180 degrees right there plus that reference angle. So theta in the third is 180 plus the 52.5 degrees for a total of 232.5 degrees. Shorthand would be 70.6 at an angle of 232.5 degrees. Longhand, you'd write it out. I'd like to squeeze this one in. So the square root of 3 is a positive number in the x direction, but the minus j is a negative 1. So it's about, square root of 3 is about 1.7. So I'll go to the right there and go down 1. And here is my vector. So again, this vector has an x value of a square root of 3 and a y value of 1. I just want you to know that if you did not use your Pythagorean theorem program, and if you took the square root of 3 and squared it, you'd get 3. And you took 1 and squared it, you'd get 1. So 3 plus 1 is 4, and the square root of 4 is 2. So my r value in this problem is just 2. To find the size of this reference angle, I'm going to take the inverse tangent of my y component, which is 1, over the square root of 3. And when you do that, you should get a 30-degree angle. This is in the fourth quadrant, so in the fourth quadrant, I'm going to circle all the way around to 360 degrees and then subtract my reference angle. So theta in the fourth is 360 minus the 30, so 330 degrees. Shorthand is r value is 2 at an angle of 330 degrees. Longhand, that means 2 times the cosine of 330 degrees plus j times the sine of 330 degrees. Again, this is called the polar form of a complex number. Remember, this is called the rectangular form. So it's just, it's like English and Spanish. It's just a different form, a different language.